process improvement.
Awareness 2.0 is important because it enhances team coordination by providing real-time updates on project tasks, developer activities, and progress. This helps reduce miscommunication and ensures that teams stay aligned. The paper explains how Awareness 2.0 uses configurable dashboards and event feeds to keep team members informed. Dashboards aggregate key project information, while feeds deliver real-time updates about changes, like task completions or new issues. Awareness 2.0 addresses key challenges in software development, such as information silos and delays caused by outdated or missing updates. It ensures that everyone has access to the information they need to make timely decisions. Unlike traditional tools like static reports or forecasting software, Awareness 2.0 focuses on real-time updates and customizable views, making it better suited for dynamic teams. Awareness 2.0 works best in collaborative, fast-paced environments like agile or large-scale projects. However, it's limited by the risk of information overload if dashboards are not configured properly or if too many updates flood the event feeds. I chose this paper to understand how real-time tools like dashboards and feeds can improve team awareness, which is a critical challenge in large software projects. I hope to learn how tools like Awareness 2.0 help teams stay informed and coordinated, especially in fast-moving development environments. The authors believe Awareness 2.0 works well because it centralizes information and delivers real-time updates, which reduces miscommunication and helps teams make better decisions faster. I agree with the author's viewpoint because Awareness 2.0 fills a key gap in software development by focusing on situational awareness. Its approach is supported by examples of how teams use these tools to enhance collaboration. The conclusions are logical, demonstrating how Awareness 2.0 improves transparency and coordination while addressing common team challenges in software development. TSP and PSP are important because they are all about improving performance on a team and individual level. Using TSP and PSP, developers can enhance their productivity, accuracy, and software quality. My paper focused on an application called Process Pair that automatically analyzes PSP data that was previously collected. It has a straightforward and easy-to-use GUI for inputting the data and visualizing the results. Process Pair uses performance models trained from large datasets, so it is able to identify performance problems and root causes more efficiently and accurately than traditional manual methods. When compared to other analysis methods, Process Pair saves time because the automatic analysis will always be faster than any human. Process Pair works best when it is supplied complete and accurate data to analyze. The paper doesn't mention if Process Pair works for TSP, they only provide examples of its use for PSP. I chose this paper because I was interested to see what kind of reports an automated analysis tool could generate. I was hoping to learn how Process Pair could enhance performance analysis, specifically relating to TSP and PSP. The authors think their method works because their tool was built on well-established statistical calculations and performance models trained from large datasets. I agree with the author's viewpoint because they showed examples of their tool working in an empirical study. I think their conclusions are logical because they are based on the empirical study results, where benefits such as reduced manual effort and improved accuracy were reported. In software development, effective use of large-scale corporate databases is crucial for process improvement and decision-making. This paper is important because it uncovers challenges in integrating metrics with organizational goals, especially in high-maturity environments like CMMI Level 5. By using frameworks such as M-3P, organizations can address software development challenges like linking defect and productivity data to improve project outcomes. Unlike basic GQM, M-3P provides a hierarchical approach connecting project, process, and corporate goals, making it particularly effective in mature organizations. However, the approach has limitations, as it assumes significant resources for designing and integrating databases. Ultimately, These methods are best applied in structured environments where data collection is a priority and processes are well defined. I selected this paper because it provides a practical perspective on the challenges and solutions for using large-scale corporate databases in CMI-level organizations. It offers valuable lessons on how to connect data collection to organizational goals, which we hope to learn more about. The authors believe that frameworks like M-3P work because they provide clear links between goals at different levels, ensuring data remains relevant and actionable. I agree with their viewpoint, as poorly designed databases often hinder insights, even with ample data. The conclusions are logical, demonstrating how structured design and goal alignment can transform corporate databases into powerful tools for process improvement and decision-making.
Burndown charts are extremely vital as they give a clear visual snapshot of how much work remains and assist us in finding problems early on. We can gauge how much work is left against an ideal line and rapidly adjust to the scenario if there is a backlog. The transparency and early detection thus enable a team to work with an always evolving requirement and continuous improvement to deliver burndown charts and agile processes. A massively successful and beneficial component. I chose this paper because it exemplifies agile adoption in Saudi Arabia, where agile is still maturing, and how tools like burndown charts enhance the team's processes. The authors describe how agile brings about quick adaptation and strong communication as features of continuous feedback. Burndown charts bring forth this visualizing progress, promoting transparency, and enabling quick resolution of issues. I am in support of this view. Agile adaptability, communication, and teamwork at work now have the burndown charts as manifestations thereof by making the progress visible and allowing timely changes. I wanted to learn how Agile fits into new markets and how visual tools help teams track workloads and adapt quickly. These conclusions make sense. Low awareness signals the need for training, and once understood, burndown charts align well with Agile's value system and help better results for teams. The burndown charts differ from the classical approaches in being flexible and dynamic feedback. They do not require upfront planning. They show progress clearly and allow for rapid changes. They work best in agile environments or iterative developments when teams are expected to frequently deliver and adapt rapidly. However, the technique has its limitations. Improper estimations or inexperience can diminish effectiveness, and it requires continuous involvement from the team for successful application.
The importance of teams and roles in process improvement. Teams and roles are central to process improvement, which systematically refines workflows, tools, and methodologies to enhance efficiency, quality, and collaboration. Why focus on teams and roles? They define how work is organized, directly influencing communication and efficiency. This is especially crucial in distributed environments like global software engineering, where time zone differences and task dependencies pose challenges. This study provides practical insights into managing distributed agile teams, highlighting Scrum, tools like FlowDoc, and adaptive roles. The goal was to understand how team structures and roles reduce coordination overhead and improve communication in distributed collaboration. The study examined how agile practices like Scrum enhance process management in global software engineering. It analyzed same-site and cross-site teams to explore how structured roles and tools like FlowDoc improved communication and coordination. While the results are partially generalizable, they were based on a student project, meaning industry contexts may vary in complexity. The authors concluded Scrum is effective for distributed teams, addressing interconnected tasks and communication gaps. However, the study lacked quantitative metrics beyond socio-technical congruence and had limited evidence for long-term scalability in industry settings. Key agile practices from the study include self-organizing teams, defined roles, feedback loops, communication rituals, and metrics. The study also showed how teams and roles improve collaboration. Teams overcame challenges with self-organization, enhancing efficiency. Scrum Masters rotated leadership, while product owners resolved delays and kept tasks on track. Retrospectives fostered continuous learning and incremental improvements.